Oh, in section 1, we learn about the coordinate plane. And the coordinate plane is named a couple different things. We've referred to it as the XY axis, the Cartesian coordinate system, named after a French mathematician by the name of René Descartes, where they've used it for a lot of different things, and mainly mapping and whatnot. But anyway, the first thing that we need to talk about is what one looks like. So, first of all, you'll have two lines running just like that. And this one is known as the x-axis, and this one's known as the y-axis. X-axis goes up and down, y-axis goes right and left. Okay. At the center of the axis, where the two axes meet, is known as the origin. The origin is known as the coordinates 0, 0, meaning that you haven't moved anywhere. That's your starting point. That's where we're going to start all these from when we're asked to graph points. So if you are asked to graph a letter, they're going to give you A, and they're going to say like 3, -4. Now when they give you that scenario like that, they are giving you positioning. They're giving you the x one first and the y one second. So what they're trying to tell you in that ordered pair is they're trying to tell you to go to the right or left first, then up or down second. Right meaning if it's positive, left if it's negative, up if it's positive, down if it's negative. So for this first one, it says I go right 3, 1, 2, 3, and then I go down 4, 1, 2, 3, 4. Make a dot. That is where point A's location is. Very similar to a GPS format, where if you were mapping a location on your GPS, it gives you latitude, longitude. Very similar to that. So I'll give you one more here, letter B. And by the way, when they label points, they usually go alphabetical, uppercase. So let's go -5 and 8. So 1, 2, 3, 4, 5. And then up 8. 1, 2, 3, 4, 5, 6, 7, 8. Now one thing I hope you notice is that I am not using graph paper, mainly because there isn't a little thing on here for graph paper, but anyway, I'm not using graph paper, and even when I do this by hand, I usually don't. I just try to make it as accurate as possible. Although it's not going to be 100% accurate, it is possible to do this without using graph paper. Just try to make sure that your tick marks are roughly evenly spaced as best you can. Okay. So as far as graphing points, that is it for that first part. Then the second thing they're going to ask you to do is they're going to ask you to graph regions. Now, when they give you something like this, and for the first time that when you see this, you might think, what is that type of notation? So let me kind of walk you through all the stuff that's here. First of all, this right here is just telling you, the thing that I underlined, is telling you what kind of coordinate or kind of plane we're going to graph it on. There's many different kinds of planes. We're going to be dealing with just Cartesian coordinate system. There's the three-dimensional system, the polar system. There's a couple other ones too, but we're only going to deal with the XY axis. So for us, that's what that means. This whole thing right here just means you're graphing on the XY coordinate plane. So that means you're going to draw a line straight up and down, and a line's running straight right and left. It is important that you make sure you label your axes, and if you notice where I put them is that I put them always on the positive ends, either to the right or to the top. Just so that way that when a reader knows, especially when we graph some of these vertical and horizontal lines, you know which one the axis is and which one is the line. So for this particular thing, the thing that I want you to identify with it is this gives you an X. So that means on the x-axis, you're going to go over whatever that number is. Now the number is 0, which means we're going to go straight up and down. If this is underlined, like it is a solid line straight up and down. So basically what I'm doing is I'm drawing a vertical line on top of the y-axis. Now, is it always going to be on the y-axis? No. But for this particular thing, when it is like that, we are making a vertical line. So x, and then a number is going to be a vertical line. Y and then a number would be a horizontal line. Horizontal meaning it runs right and left. Okay? Now the next part is when this says greater than, like this symbol right here says greater than, we want to shade or color in the spot that is bigger than 0. Well, bigger than 0 on the x-axis would be everything over here. I'm not one for coloring much, but at least with my shading purposes, I'm just going to kind of rough one in there just so that I can see, hey, that it's going on forever that way. And that's what I mean by shading a region or graphing a region. Now, the next one that I'm going to give you is very similar to this, except for now we're going to deal with a y. So I've got x, y. Again, that's just a notation thing. -1 is less than y, which is less than 1. This also notation could be the same thing as the absolute value of y is less than 1. So just so that you know that those are the exact same things. So as I draw my axes, since it is a y, I'm going to go up and down and make my lines. First one I'm going to do is I'm going to do the positive 1. So I'm going to go up 1. And now this is not underlined. If it's underlined, we make a solid line. If it's not underlined, we make a dashed line. Dashed lines are similar to the open circles, which means it comes right up to it, but does not actually include it. So it's like an invisible fence for a shock collar on a dog. You know, it comes right up to it. Once it hits it, it gets shocked. Same kind of thing. You just want to go right up to it, but never actually touch it. Now the next one I'm going to do is the -1, which means I go down 1, and I make the same dashed line. Now, what I'm doing by dashing again is because it does not say equal to. If this were underlined either here or here, then I would make that a solid line rather than a dashed line. Now, as far as shading it goes, what I'm going to do is I'm going to just focus in on this side of it right here. That side of it says y is less than 1. Well, 1 was on top, so less than 1 means everything down below. But on the other side, it says greater than -1. So it's everything in between. So as far as my shading my region go, that is what we're going to have to do. Now, I hope you notice that, you know, like I said with the y equals and the x equals was vertical lines, which means straight up and down. Y equals means right and left. Okay, and that's as far as shading wise goes. We'll do more of this later on, but for now it's just horizontal and vertical lines. Then the next part that we're going to deal with the distance formula. Now the distance formula is something that has been around for years, thousands and thousands of years. It's actually a direct descendant from the Pythagorean theorem, if you remember that from your high school days, where you're finding the missing side of a right triangle. But the distance formula is basically how do I find the distance between 2 points? Okay, so there's a couple different ways. One of them is you can actually make a picture, or there is a formula. I prefer the formula, however, it is totally up to you. I'll show you both, and then you make the decision which way you want to go with it. But the distance formula is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Now what x2 and x1 mean and y2 and y1 mean is just the first point and second point. It's not squaring it. The number up on the top, this right here would be squaring it, which means I'm going to multiply by itself. But this number down here and here, that just means first and second, like the first position and second position. So the first thing I'm going to do is I'm going to just come up with two ordered pairs. So I'm going to say A is 2, 5, and B is 4, -1. Now, using the formula, I labeled this as x1 and y1, and then this is x2 and y2. And the reason why I'm doing that is because A was first and B was second. Does it matter? No. Just make sure you stay consistent with which one is the first point and which one's the second point. It really does not matter which one you use as the first one or the second one. You just have to stay consistent. So as far as the formula goes, when I plug it in, and I'll show you what I mean by consistent here, x2 is 4 minus 2. Now, I went with this one first, or x2, and then this one is x1. I cannot switch that around just because it makes it look better for the y's. I gotta stay with this one's the y2 and this one's the y1 then. Otherwise it will not work for us. Okay, so then all I did was inserted my numbers into where they belong. If you notice too that I labeled these on top of the order pairs like x1, y1, x2, and y2, and the reason why I do that is because it keeps me to know which one's which, so I don't get it confused, so I'm not screwing it up. Alright, so I do that still to this day. Now, when you're doing this next, you're going to do the order of operations. So the first thing we're going to do is 4 minus 2, which is 2 squared, plus negative 1 minus 5 is negative 6 squared. Next thing then happens is we need to square both things. Okay, so when we square both of them, 2 squared is 4. And this is a part that a lot of people mess up here. When I say negative 6 squared, it's not negative 36. You're not putting negative 6 into a calculator and squaring it, which if you put it in like this, it will tell you negative 36 because it's telling you the opposite of 6 squared. But if you put it in parentheses like this is, it will give you the positive 36, which is what we want. By the way, that should never be negative. When you're squaring a number like that, you should always get the positive. And then you end up taking 36 plus 4, which is the square root of 40, which when you use your calculator is approximately 6.32. Okay? So as far as that goes, it's going to say to round, or if it doesn't say to round, just go 2 decimal places is probably as good as it needs to be. But that's how I use the distance formula. Another way to do that same problem is, let me put the order pairs down there, and I'm going to look back just to see what they were again, is if you graph it. Now 2, 5 would go up, or over 2, and then up 1, 2, 3, 4, 5, make dot, and then over 4, down 1, make dot. Now the shortest distance between 2 points is a straight line. Now what I could do is I could end up making a triangle out of this. And now this is why I mean by this is the direct descendant of the Pythagorean theorem, is because now I've just made a right triangle. Where all I would have to do is count this is 2 spaces, and this is 1, 2, 3, 4, 5, 6 spaces this way, and now I'd end up doing a squared plus b squared equals c squared, which is the Pythagorean theorem. One leg squared plus another leg squared equals the hypotenuse squared. 36 plus 4 equals c squared. 40 equals c squared. And then get rid of square, you square root it, which again is approximately 6.32. So either way, it is acceptable. The difference with this is that obviously the numbers are not that big yet. However, they could be fairly large, and to draw triangles that would be as big for all your stuff and accurate. It's really hard to do when you're not using graph paper. Plus, using especially if you are using graph paper and getting a bigger things, that could really throw you off quite a bit if you're off. So, but anyway, those are the 2 different ways. As far as the distance formula goes, that's all I would do with those, is do it one way or the other. Me personally, I prefer the formula itself just because I don't want to draw every time. However, I could go either way with that, and it's totally up to you, whichever way you want to do it. The next formula that we also have in here is we have what we call the midpoint formula. Now, midpoint formula is a way to find the middle point. So if you have your 2 points, and let's say that those are miles apart, and you wanted to stop halfway, and get gas or whatever, that's exactly what the midpoint formula does, or the midpoint does. And the formula for it is x1 plus x2 divided by 2, y1 plus y2 divided by 2. Now what you're actually doing here, and a surprise to some people when you actually say this, but you're finding the average between the x's and the average of the y's. It is listed as an ordered pair format because it is an ordered pair. It's a point. So if we use that same 2 points, A was 2, 5, and B was 4, -1, we're going to find the middle point. And to draw this would be kind of hard to do, but the formula is fairly simple. 2 plus 4 over 2. Now what most people do wrong, these are the x's. These are the y's. Not the other way around. A lot of people do 2 plus 5 and then 4 plus -1, and they're adding x's and y's together rather than both x's and both y's. So be very careful with that, because that does tend to throw you off. Okay, now the first thing that you want to do is you want to add or subtract the tops. So 2 plus 4 would be 6. And then the other one, 5 plus -1 would be 4. And then to simplify that, 6 divided by 2 is 3, and 4 divided by 2 is 2. So the middle point between those two would be 3, 2. Alright? So as far as the assignment, when you look at what I'm going to ask you to do, the first things it says is to plot the given points, which that would just be plotting them and see what you get. Then I give you a couple that says sketch the region. Then I give you a couple that says find the distance and find the midpoint, which I just gave you distance and midpoint. Same thing through there. Show that the points are the same distance to the origin, which would be just using the distance formula. When it says distance, use distance. And then the last ones it says if M is the midpoint of the segment and has one of the coordinates, find the other coordinate. So a problem that's similar to that would be if I gave you A was 2, 5 and I gave you the midpoint was 3, 2, okay, then what you would do is you would work backwards. So it would be, if you were looking for what is B, then you would take 2 plus x divided by 2 equals 3. Now where did I get the 3 from? It's the x coordinate of the midpoint. I would multiply both sides by 2. So I get 2 plus x equals 6. Subtract 2, and I get x equals 4. And then I do the same thing for the y's guy. I would take 5 plus y divided by 2 equals 2. Times it by 2 to both sides. 5 plus y equals 4. Subtract 5, and y equals -1. So just so that you know that you'll have a problem, you'll have to work backwards like that in this section. So hopefully that helps. That's section 1 of our college algebra book. So talk to you later.